Welcome back to Larbi Premium Consult. On this channel, we cover business courses and mathematics courses. In this video, we are going to look at probability. So if you are new on this channel, kindly consider to subscribe, like, and share. So let's begin with this video without wasting my time. So somebody may ask, what is probability? What is probability? We are saying that probability is a measure of likelihood that an event will occur. The measure of likelihood that an event will occur is what we call what? Probability. So we're talking about likelihood. Likelihood that an event will occur. That's what we call what? Probability. So we may ask, what is the probability that party A or party B may win an election? What is the probability that party A or B may win an election? Alright? Or what is the probability, let's say, party A will win an election? It is either he will win or he will what? Lose. The chance of A coming out with the election results can be that either he will win or he will lose. And this is going to be based on the percentage or the fraction or the proportion of the sample of the total population that is able to, accrue from the election result. That's what we call what? Probability. So it's always based on the likelihood that an event will occur. So the probability that A will win or lose is not certain. It is based on the number of votes that you will be accruing at the end of the day. So that is probability. So probability, we're talking about the likelihood that an event will occur. So we can say that, for example, what is the probability that you may pass examination or you may not pass? This is not certain because the event hasn't occurred. So once the event occurred, then we are saying that then we can measure the probability. So we are talking about likelihood. It is certain that an event may occur or may not occur. That's what we call it, or that's what we mean by what? Probability. And this is what you need to understand. It's a measure of likelihood that an event may occur. All right. So that is probability. If you have any question, kindly comment below so I can give a response to that in that case. So this is just an introductory part. So as we always do, we'll be looking at what? The direction that we'll be going through when it comes to probability. So we'll be looking at the introductory part as we have already dealt with it. Then we're looking at certain key terminologies and probability, and we're looking at the approaches that we may go through and probability. That's what we're going to look at in this video. Look at the key terminologies and the probability, and look at the approaches that we follow in probability. So that's what we're going to look out for. So kindly stay tuned. If you are new here, kindly subscribe, like, and share that and get more engagement on this video. All right, so let's get onto it. So we are going to look at, we have done with the introductory part where we look at the meaning of what? Probability. So we are going to look at the key terminologies, and the first key terminology that we're going to look at, is what we call an experiment and experimental outcomes. Outcomes. Okay, I think that is here. Experiment and experimental outcomes. Right. So what is an experiment? You are saying that an experiment is a process that generates what? A well-defined experimental outcomes. For example, when you conduct an examination, you'll get a result, and the results will be that either you achieve success or you fail. So let's say we conduct an examination for students at the tertiary level, or let's say we conduct an examination on statistics for KSB level 100 students. the result will be that either they will pass or they will fail. The process that we go through to generate whether the student pass or fail is what we call an experiment. And the outcomes, what we call an experimental outcomes. So that's why I've given you an examination. It's an experiment. An election is what an experiment. So the results that we derived from the examination and the election is what we call an experimental outcome. So here it is certain that either in examination a student will pass or will fail. That will be the outcome. When it comes to election, it's either the ones contesting for that position will either win or what will lose. That's what I mean by what an experiment and experimental outcome. I hope that is clear. Good. So that is an experiment and experimental outcomes. Let's talk about sample space. We are saying that sample space is also a set of all possible experimental outcomes. Give us what we call a sample space. So basically, experimental outcomes will result in what we call a sample space. For example, tossing of what a coin. It is certain that we may have what either a head or what a tail, and that will be our sample space. Rolling of what a die. It is certain that we may either get 1, 2, 3, 4, 5, or 6, and this will be what we call our sample space. So sample space is basically the outcome of what experimental results. So when we pull all the experimental results together, we get what we call a sample space. It's a set of all possible experimental outcomes upon which that an event will occur. So that's a sample space. Then we come to a sample point. A sample point, this one. A sample point, we are saying that a sample point is a single value in a sample space and is an element or a single value in an experimental outcome and also an element in the sample space. So for example, if I take the head, this head is one of the outcome of tossing a coin, and it becomes what at the same time element of what a sample space. That's what we call what a sample point. So a sample point is an individual experimental outcome that we take from the sample space. So it is just a particular experimental outcome, and which is also an element of what a sample space. So take note of that. That's a sample point. All right, so let's continue. And also have we call what a trial. We are saying that a trial is basically what a single what performance. A single performance. A trial is a single performance. So if I toss a coin once, that is the first what trial I've undertaken. That is the first. If I toss a coin for the first time, that's what a trial. If I toss the second time, that's also another trial. If I roll a die for the first time, that's what a trial. If I roll it for the second time, that's also what a trial. So a trial is basically a single performance of an experiment. All right, and once you perform any experiment, it is certain that you're going to get what an outcome. And I think you have already defined the outcome from the experimental outcome, where I define it that it is the result that is generated by undertaking an experiment. So an outcome here is a result of what? An experiment. A result of what? An experiment. So take note. An outcome is a result of an experiment. Then, having gotten an outcome, there's also what we call what? An event. We are saying that an event is a collection. An event, this event, is a collection of one or more experimental what? Outcomes. A collection of one or more experimental outcomes that is likely to happen. So for example, I take, let's say, tossing of a coin. It is certain or it's likely that a head may occur or a tail may occur. So when I record whether a head or a tail that will occur, when I record these two events or these two outcomes is what we call what? An event. For example, if I want to do an inspection of my machine, then I check it is either part of the machine, there will be a defective on the machine, or it will be what? Defective. And when I record the two, is what we call what? An event. So an event is actually like an experiment. Okay? So it is either there will be a defective or non-defective of my machines when I inspect the parts. Alright? Or when I'm into tossing of coin, it's either I'll get a head or I'll get what? A tail. And that's what we call what? An event. So an event is actually a collection of one or more sample outcome. One or more, experimental outcome that is likely to what happened. So that is an event. So as I given here, if I have what? Tossing of coin, is either I get a head or tail, and this will be my event. And if I do an inspection of my machines, it's either my machine that I use in production, it can be either there will be defective machines or there will be non-defective machines. That's what we mean by what? An event. I hope that is clear. So if you have any question, kindly put below in the comment section and I'll give responses to that. So having had these key terminology, let's move straight away to talk about an approaches to probability. Approaches to probability. Go to this part. And approaches to probability. Basically, we have two approaches to probability. We have what we call first an objective view and subjective view. So I would like to start with the subjective view. When you talk about the subjective view of probability, we are saying that under the subjective view of probability, the idea is that there is no previous or past information. There is no previous or past information. And in that, once there is no previous or past information, based on the event that is likely to occur, it will take into account whether there is any available option or information that is available for such event to occur. And because it doesn't have any past or previous information, it takes into account any information that is available for it to operate. Okay? It takes into account any information that is available for it to operate. And that's what we call a subjective view approach. And in that, because there is no information, there is certain that there may be some biases when such approach is used in determination of a probability of an event. Like probabilities lie more like a predictions. Okay, that you are saying that it will rain. What is the probability that it will rain? You are making a prediction. Alright, it can either rain or it won't rain. But here you don't have any previous information or previous experience that will tell us that it will rain or it won't rain. So anytime we are into such approach, then we are talking about subjective view of what? Subjective view of what? Probability. Alright. So that's what I mean by what? A subjective view approach in probability. So for example, if you are estimating the probability that you will end an A in statistics. For example, you are a first year student at KSB, right? Level 100 students that you are studying what probability and you'll be writing an exam. You haven't studied probability at KSB before, so you don't have any information or you don't have any experience about how even the question is set, the number of questions that will be coming up, and how even the approach that you should go by to solve the question, right? You don't have that experience. So when you are making an estimation that you get an A, it is certain that you are going to get the A or won't get it. But at least if you have had a previous idea or previous information or previous experience about how statistics is conducted, the number of questions that the set, who says it, and how these are undertaken, then at least you could make an estimate that I can get A based on this information I've derived. But here the assumption is that you don't have any information about it. So when you are making an estimation, it is possible that there may be some biases or doubts about what you are saying now. That's what we call a subjective view approach in probability. So that is subjective view. There is no past information that is available for you to estimate. We can also say you are estimating the probability that, let's say, Ghana will win, let's say, the next coming World Cup. Ghana will win. Though we haven't undertaken that activity, but you are making an estimation because you don't have any information. So it's certainly that Ghana will win or won't win. But if you have had some previous idea or previous information that Ghana went to African Cup or any World Cup and then they win, then at least based on the strategies that they use, you can, based on that and information, you can make prediction that then it's certain that this year's World Cup or any activity they will do, they will win. In terms of football, that's what I mean. Okay, so that is subjective view. But when it comes to the objective view, the reverse is true. That is, here we have previous information that help us to make an estimation or prediction that certain event is likely to occur. So that is the two. And under the objective view approach, we have what we call a classical probability and an empirical probability. So let's look at them real quick. So what is a classical probability? So with a classical probability, it is actually a probability that looks into the number of ways in which an event will occur, taking into account the number of ways in which the sample space can occur. And I will explain this in a moment. So when it comes to classical probability, as we are saying, the idea is that probability is more like you are making assumptions because you don't have the concrete information as to whether an event will occur or not, unless an experiment is performed. Then you'll be able to know that if this event is certain to happen or not. So when it comes to classical probability, it is based on the assumption that the outcome of an experiment, the outcomes of what? The outcomes of an experiment, let me have it here. The outcomes of an experiment, that's plural. Outcomes of an experiment are likely, or of an experiment are equally likely to what happened. That's what we call a classical probability. They are equally likely to happen. So for example, let's say a tossing of coin is either you get a head or a tail. So it's likely that both of the head or tail has a chance of happening or occurring. That's what we call a classical probability. And in that, you take into account the number of events that such situation will occur, taking into account the number of sample space that can occur. So if it's a head or tail, and then at the end of the day, tail occur, then we say that, or we are estimating that when we toss a coin, tail will occur. Then we can say that it is a tail, which is 1 divided by the total sample space that we have defined as is a set of all possible outcomes, which is head and the tail divided by 2. And you get what we call your classical probability. So number of ways in which an event E occurs divided by the total number of ways in which the sample space can occur. And in short, I've written them as number of events over the number of sample space. Now I hope that is clear. Remember, we said an event is a collection of one or more sample outcomes. You remember? Good. So that is why we are having it here. Number of events over total number of sample space. So let's take an example. This is our first example. Consider an experiment of rolling a 6-sided die. What is the probability of the event I, an odd number of spots appears up, II, an even number of spots appears up, and III, multiples of 3 number of spots appears up? So when we take this, so first of all, you must know your sample space. The sample space is basically a set of all possible experimental outcomes that are likely or that have equal and likely chance of what it occurring or them occurring. That's what we call it a sample space. So the sample space will be a six-sided die, which consists of 1, 2, 3, 4, 5, and 6. So that will be our sample space. And based on the requirement, you can know the event for each requirement in that case. So let's sort it out. Let's work it out and know how it is undertaken. So in our example, we said that a six-sided die is what thrown. That is the experiment that we are undertaking. So if that is the case, then we can say that let X represent the sample space for the die, and which will be 1, 2, 1, 2, 3, 4, 5, and 6. And the first question that they asked us to do is to calculate the probability of an odd number spotting up. So what is an odd number? So here, let me also use A to represent what the odd number. So the odd number within this sample space will be what? 1, 3, and what? 5. So therefore, we can say that the probability of an odd number appearing will be probability of A, which will be equal to the number of what? Event A over the total number of the sample space, which is going to give me what? So I know A is what? 3. 1, 2, 3. So it becomes 3 out of what? 6. And I'll be getting what? 0.5 as my probability. I hope that is clear. So that is the first, then that is the first requirement for the probability. Then II. We are asked to find the probability that an even number will appear. And let's say we use B to represent the event for even number. And that will be, so even number from the sample space will be start from what? 2, 4, and 6. Alright, so in that case, I can say that therefore the probability of B occurring is equal to the number of what? B divided by the total number, which is what? The sample space. And in that it becomes what? 3 over what? 6. Because you have 1, 2, 3, and the sample space is what? Number of 6. Alright, so here it becomes what? 0.5 as the same as the odd. Then the last one, we are having III. So let me say, let that one to be represented by what? C. So what is the multiple of 2 that we can get from the sample space, which is 1, 2, 3, 4, 5, 6. So we start from what? 3 and what? 6. We are going to get what? 2. So in that, if I want to determine the probability of multiple of 2 within a sample space of 1, 2, 3, 4, 5, 6, then that will be the number of what? Event C occurring divided by the total number of the sample space that can occur. And that will give me what? So here is what? 1, 2. Alright, so it becomes 2 out of what? 6. And that will give me what? 1 out of what? 3. Okay, good. So you can even convert it. So here too, we can have them as 1 over 2, 1 over 2. You can change it on to decimal place where you're getting some 0 point in that decimal form. Yeah, 0.3333 in that decimal form. So let's take note of that. So that is the classical probability. Alright, so let's move on to the other one called the empirical probability. So we just discussed the classical probability where we have solved an example, right? So we are moving on to the empirical probability. So when it comes to the empirical probability too, the idea is that here the probability of an event occurring is actually based on the previous event that has already occurred. Please listen very carefully. When it comes to the empirical probability, the idea is that the probability of an event occurring now is based on the frequency of an event that has occurred in the past. The frequency of an event that has occurred in what? In the past. That's what will give us what we call an empirical what? Probability. Let's take note, please. So that's what we mean by what? An empirical what? Concept. That's what we mean by an empirical concept. So when it comes to estimating the probability of an event occurring now and under empirical concept, it is based on the frequency of an event that has occurred in the past. Okay, so in that we can say that the empirical concept in determining the probability and the empirical concept will be the number of times event E what has occurred in the past. Please take note of this. Has occurred in what? In the past. Divided by a total number of what? Observation. And that will give us the empirical concept of estimating the probability that an event would occur in the future. Or is certain to occur or will not what? Occur. So that is the empirical concept. Let's use an example to clarify this concept and to make it so understandable for you to appreciate it well. So there's an example. I read, a study of 800 students of level 100 in KSB was conducted last year, 2019. A study of 800 students of level 100 in KSB was conducted last year, 2019. It revealed that 530 of the 800 students did pass business statistics. What is the probability that the current year student of KSB level 100, that's level 100, will pass business statistics given the previous years? So once you heard of the previous years, then you are thinking about an empirical what? Probability, because it is a probability that is based on the frequency of an event that has occurred in the past. So here, how are you going to come out with the probability? It's very simple. Straight away, just look at the event that occurred in the past. Taking into account the event that occurred in the past, then taking into account the total number of observations that we observed in the past. So in the question, you can see that a study of 800 students will be the total number of observations that we observed in the past. And then it will be that 530 out of 800, so the 530 will be the event that we observed in the past out of the sample of what 800 was students who passed what business what statistics. So if we base on the previous information, then we can estimate that this is the probability that students may pass this current year business statistics exams. That is the assumption about the empirical concept. So let's solve it and know how it is done. So I can say that let my sample space be what? Let my sample space be 800. So 800 students. Okay. And then let those who passed, let me say E, be equal to what? 530 students. All right. So therefore, I can say that the probability that event E will occur is equal to the number of what? E that occurred in the past, which is the 530, divided by the total samples number of what? Observation, which is X. So here straight away, it becomes 530 out of what? 800. And let's see the outcome. So when I divide 530 over 800, I had 53 out of what? 80. And if you want to convert to decimals, it becomes 0.6625 in that case. So this will be my probability in that case. So this is where we bring an end to part 1 of probability discussion that we are having. If you was helpful to you, please consider subscribe, like, and share. So in our next video, we're going to look at the probability part 2, and in that we're going to discuss the rules some rules under probability. So I'll see you in the next video where we discuss some rules under probability. Bye bye.